This is the second video of the first lecture, video 1B. So now we're going to talk about something related to the alternating series test called convergence or absolute convergence or convergence absolute. So first of all, let's start with the definition. We say n equal 1 to infinity bn converges absolutely if the absolute value of the bn n equal 1 to infinity converges. I'm using bn because sometimes the an has alternating terms in them, so you combine this and call it bn. Okay, so let's take a look at, as an example, n equal 1 to infinity minus 1 to the n minus 1 over n. Okay, and you will see here the bn is minus 1 n minus 1 over n, and so n equal 1 bn is n equal 1 to infinity minus 1 n minus 1 over n. But this absolute value, this is the top number. Let me give you all the details. But this number is either minus 1 or plus 1, and you're taking the absolute value of it. So this is n equal 1 to infinity 1 over n, and that diverges, remember? So this series does not converge absolutely. So n equal 1 to infinity minus 1 n minus 1 over n does not converge absolutely. Okay? So that series does not converge absolutely. All right. So I'll give you some time to copy this down. And Lily, حاجة قولي لي هالشطورة. يلا move. يلا move. Okay. I think Lily is getting hot. Okay. We have a theorem. If bn converges absolutely, then it converges. Okay? So if the series converges absolutely, then it's convergent. All right. Okay, so let's try to do the proof. So here is the proof. Suppose bn converges absolutely. Okay? And now what do we know? We know that bn, okay, is thus equal to minus bn, or may I say, sorry, this one bn. Okay? Now add bn to both sides. And this is less or equal to 2 bn. Okay? Is that clear? So what we did? So remember, so what did we say? We said if bn converges absolutely, then this bn converges. So let's take this, let's sum both sides. So if I do sum both sides, so what I have is 0 less or equal to bn plus bn, and this is less or equal to 2bn. Is that right? So this means 0 less or equal to bn, this is less or equal to bn. But remember, this converges, and so that one converges. Okay? So this one converges. Why? Because the series converges absolutely. That means this converges. So, and this is less or equal to that by the comparison test. So by the comparison test, this one does converge. Okay? All right. So if the series converges absolutely, then it converges. However, the other way around is not true. Remark. Convergence does not imply absolute convergence. Okay? So what I'm saying is convergence does not imply absolute convergence. All right, and here is an example. N equal 1 to infinity minus n minus 1 to the n. We showed this converges by the alternating series test. Is that right? However, n equal 1 to infinity minus 1 n minus 1 over n is n equal 1 to infinity 1 over n diverges. So this is an example of a series that converge but does not converge absolutely. In this case, that series has a name called conditional convergence. So that brings us to conditional convergence. So definition. If Bn converges but does not converge absolutely, then we say it converges conditionally. So the series converges conditionally because it does converge but not absolute convergence, and n equal 1 to infinity minus n minus 1 over n converges conditionally. Because we just saw that the series converge, but it does not converge absolutely. Okay? So we've done, maybe the terminology is a little bit difficult to understand altogether. But on the other hand, so basically what did we do? We just did the alternating series test, getting ready for the conditionally convergence. So we did the alternating series. That alternating series tells us only about convergence. And then from there, the alternating series has negative terms. So if you take the absolute value of everything, everything becomes a positive, and that new series was all positive term. If it converges, then we say it converges absolutely. Now, Lily, come here. Now, if the series converges but does not converge absolutely, then we say the series converges conditionally. Okay? And we just give an example. All right. So absolute convergence implies convergence. Listen to me. absolute convergence implies convergence. Convergence does not imply absolute convergence. And if the series does converge but not absolutely, then we say the series converges conditionally. Basically, this is it. That's the whole lesson. And we can come up with a lot of examples and so forth. And for example, here, for example, if you want absolute convergence, n equal 1 to infinity cosine n pi over n squared plus 1. Okay? Well, if you look at this, this is n equal 1 to infinity minus 1 to the n, because for n equal 1, that is minus 1 over n squared plus 1. So by the alternating series test, I'm going to write it like this. So this is by the alternating series test. So this converges. But actually we can say more about this series. Look at that. If I take the absolute value, and this is n equal 1 to infinity, 1 over n squared plus 1, and that is less or equal to 1 over n squared, we know that converges by the p-test or the integral test. So that series converges absolutely. So n equal 1 to infinity cosine n pi over n squared plus 1 converges absolutely. Okay? So sometimes you're going to see a lot of questions in the following, are posed at you in the following manner. Decide whether the series converges, diverges, absolutely converges, or conditionally converges. You see all that? Okay? Well, series, the only time you have to test for absolute convergence is when the series has negative term. It alternate negative, positive, negative, positive. Then those series, you'll immediately look at absolute value and see if it converges. If it converges absolutely. If it converges absolutely, then you can say it converges absolutely, and therefore it converges. Now, if it does not converge absolutely, then you can try the alternating series test and see if it converges, and if so, then it converges conditionally. Is that clear? I know there's too many technical words thrown at you, but you're smart enough, you can figure it out, and I'm gonna give you some homework problems for you to practice. Lily, you are so busy, Lily. Okay? No. Okay, so we're gonna have some homework problems on page 6 to 2. Number, Lily, no.